This example will cover the methodology that's required for you to be able to estimate the sample size needed to produce a specific error in an estimate for a population proportion. So previous to this, we have the idea that proportion or sample proportion is going to be the point estimate for our population proportion plus or minus an error, where the error is given by z alpha over 2 p hat q hat over n, and we have to rearrange this equation for n in order to find the minimum sample size required. So if we take this equation and square both sides, and then rearrange for n, we end up with an equation that looks like this. Z alpha over 2 over error, p hat times q hat. So note, in order to use this, it requires an estimate from your sample proportion in order to use. So if we have that information, you use the p hat and the q hat. But if we don't have that information, you just pick a worst case scenario, the one that will give you the largest product. And that's where they're both 50%. So in that particular case, z alpha over 2 over e squared times p hat times q hat, if you multiply 0.5 times 0.5, you'll end up with z alpha over 2 over error squared times 0.25. So in the situation where we have information about the population proportion, or sorry, the sample proportion, then we use this equation. And in the situation where we don't have information about the sample proportion, we use this equation. So a typical example would be something like this. Let's say insurance companies want to estimate within, let's say they're looking for a 3% error. The percentage of drivers who talk on their phones while driving. And if we use a 98% confidence interval, how many drivers do we have to survey in order to get this error? Well, if we assume that we have a proportion of 22% of drivers talk on the phone. So let's say we actually knew that piece of information. Then in this case, p hat is 0.22, and therefore q hat has got to be 0.78. If we use a 98% confidence interval, that means alpha is 0.02, and so alpha over 2 is 0.01. So if we use a 98% confidence interval, where we try to estimate the population proportion with our sample proportion, in these little tails on either side of the distribution, we have alpha over 2 is 0.01. 1% is in either tail if 98% is in the middle. So if we look up an area of 0.0100 on our table, z-score table, the area that is closest to 0.01 is somewhere between negative 2.3, plus or minus 2.3 and 2.32 and 2.33. It looks like it's a little bit closer to 2.33. So that's the one that I will use. We use Z alpha over 2 of plus or minus 2.33. That gives us a sample size requirement of 2.33 over the 3% error that's desired. We have to square that, and we multiply by the product of p hat and q hat. .33 over 0.03 squared times 0.22 times 0.78, we end up with an estimate 1035.11. We always have to round this up. So a minimum sample size of 1,036 drivers is required. If we didn't know that sample proportion, so if p hat is unknown, we have the same confidence interval, the same z-score, but n would be z alpha over 2 over e squared times 0.25. So 2.33 over 0.03 squared times 0.25. And notice the sample size is slightly bigger. Since we have to round that up, the sample size requirement is 1509 drivers. So in order to produce a 3% error with a 98% confidence interval, the sample size requirements are 1,036 drivers if we have a measured sample proportion, or minimum 1,509 drivers if we don't have the information about the sample proportion.